there is a question to discuss in JEE Advanced 2013 paper 2 of physics, which stated that there is a coaxial combination of a solenoid and a long infinite cylinder which were carrying currents. So we can look at this system here. There is a long infinite cylinder which was carrying the current parallel to the axis. So this is the axis, coaxis, axis for the cylinder and solenoid both. So this cylinder is carrying the current parallel to the axis, and the solenoid, as we all know, there are the infinite turns and number of turns per unit length on this infinitely long solenoid. Okay, fine. So we are going to discuss option number C of this question. So where there is a bit of controversy. Okay, I would not like to say controversy, but we have to discuss this question, option, which asks for the net magnetic field at a distance small r, which is lying somewhere here. It is greater than capital R and less than capital 2R. So the tip of this pen is showing this point P. So this is point P, which is lying somewhere between capital R and capital 2R. Okay, fine. So as we all know, magnetic field can be added vectorially. So we will find the magnetic field because of this combination and this combination at this particular point P. Okay, fine. So because of this, a long cylindrical shell which is having a current which is parallel to the axis, according to the Ampere's circuital law, we can say the field is perpendicular to this direction, or we can say the field is magnetic field is forming closed loops around this cylinder. So we can say it is at this particular point tangent to a circle of radius r, having center at the axis of this cylinder. Okay, fine. Now the field is also parallel to the axis here, parallel to the axis because of the solenoid. Because in solenoids, infinitely long solenoids, inside the solenoid, the field is always parallel to the axis. So what we can see, there is a combination. See, this is the field because of this cylinder, according to Ampere's circuital law. Okay, it is forming the closed loops. Fine. And this is the field because of this solenoid. I can place it like this. See, I can place it like this. So this is forming like this, and this is like this. Okay. So at this particular point, the field because of this long cylindrical shell, and this is because of solenoid. So the net vector sum is in this direction. Okay, fine. So now, what the solution given to us on the JEE website is saying that this net magnetic field is not the tangent to the circle of radius r centered at the axis of this combination, where we a bit disagree to this solution. Why? Let us see this. So this is the axis, and this is a small radius r circle. This is small radius r circle, and this is the axis. Okay, fine. So what we can see is, again I'll take use of this diagram. It says this is the field parallel to the axis. Okay, let me show it like this. This is the field parallel to the axis because of solenoid, and this is the field perpendicular, or we can say tangent to this circle. This is because of this long cylindrical shell, and this is the resultant. Now what you can see is, fine, what you can see is, I'll keep this axis here only. I'll not change the radius of the circle, and I'll rotate this circle. See, I'm rotating this circle. You can do this from here. Let me pin this up here. Let me pin this up. Fine, so that you can easily see this. Now, what we were saying earlier, that this is tangent and this is parallel to the axis, then we can say this is also a tangent to the circle having the same axis. See how? Okay, now we can see this is also the tangent to the circle of radius r having this center at the axis. See, center of the circle is on the axis. The radius of the circle is again r, and this net magnetic field is tangent to this circle. Okay, fine. So this question which says in the region capital R and capital 2R, small r is lying between these two values, the magnetic field is tangential to the circle of radius small r centered on the axis. This should be the correct option. Thanks a lot. And what I would like to say again is, please do not penalize the students who have ticked the option C also, and they should be awarded marks. Thank you. Thanks a lot.